Correlation versus causation. In general, causation refers to the causal mechanisms that one variable, one attribute, often called the independent variable, has on another variable, the dependent variable. And this can be partially observed as a correlation between two variables over multiple instances. So, for example, regarding the relationship between smoking and cancer, by observing various people, hundreds, thousands, maybe millions of people, and noticing that there is a correlation between smoking, which we can think of as the independent variable, the causal variable, as correlated with the cancer risk dependent variable. We see it in the data. Now, actually, I don't know where this data comes from, to be honest. I found it on Quora, but I couldn't find the source, but it doesn't really matter. It's here for illustrative purposes only. So the idea is that years of smoking, the more you smoke, has a positive correlation with your risk for cancer, lung cancer in particular. Okay, so the relationship is positive. There's a correlation. Now, this by itself does not indicate that smoking causes cancer. So it's just a step toward understanding that smoking causes cancer, because usually we need to look into the causal mechanism itself. So why, and we get that by answering the question, why does smoking cause cancer? We see it's correlated. Okay, that's good. It's an indication, but why does it do it? So correlation is not necessarily causation. Causation will usually involve correlation. So if one thing is causing another, and we have especially a large N, numbers of people, we should see the correlation, but not the other way around. Just correlation itself does not include causation, although causation usually involves correlation. To understand causation, one needs to understand, once again, the causal mechanisms and carefully study those processes and maybe the correlations of those causal mechanisms in the domain of interest. So we need to look deeper. So for example, are the lungs of people that are smoking somehow behaving the same and regarding the cancer and the smoking? So going deeper into it, we can actually find the causal mechanisms of something. Let's look at this example over here. Is this correlation or causation? And I have an extra question also. What is pairing the X and Y data in this graph to bring up that concept of paired data? So let's take a look at it. We have two numbers here. Some murders in the US rate. And actually, I think so murders in US is on the left side. Doesn't really matter, to be honest, but these are the murder numbers here. And this is Internet Explorer market share. And you can see they are correlated. They're moving together. As murder rates goes down, so does share of Internet Explorer, which is a browser for computers. So they have nothing to do with each other, but you can see they move together. Now, this may be kind of a silly example, but just to emphasize the point that correlation is not causation. I think a more interesting question may be, what is pairing the X and Y data in this graph? We talked about pair just on the previous video. What is pairing them? Think about it. Well, what is pairing them is the year itself. So in 2006, Internet Explorer market share was this, and murder rate was this year. It's around 17,000. And market share was around here, 85%. Okay, and this other year was, these measures were this, and in 2000, this other year, the measurements were this. So the year is not a very good pairing because many things are happening in the year, right? So many things are happening in a year in so many different places, even within the US alone. So it's not a very closely pairing thing. It's not like getting two attributes of the same person or the same individual as when we talked about height and weight. So this is kind of important to recognize too, and just because two things are happening in the same year doesn't really mean they are paired together, although you could just put the data in a data frame like that. So we got to be careful by understanding the domain. Another example here, shouldn't higher GDP lead to higher median household income? See the data here, the blue, real median household income in the United States, the red, real gross domestic product, GDP per capita, which is all the expenses, costs, and inputs, incomes, and expenses of in the economy. You see the GDP going up, up, and up, very high, but you see the median household income kind of not going that high. And actually, I showed a graph before of getting this broken down. If you see, for 85% of the population, it's flat, it's here. So this growth in higher real median household income is being pulled by some of the higher percentage of a smaller percentage of the population. Either way, the real gross domestic product is going up a lot, but income is not. So they are shouldn't higher GDP cause higher median household income? Should, but it's not really pulling it that much. So the correlation is not that strong, although it'd probably be a little bit strong if we calculate it from this data. So even with closely paired data, for example, assessing two attributes of the same individual, it is difficult to determine causation without experimental evidence, that is controlled experiments, randomized controlled trials, as you may have heard about in context of medical studies, for example. But you can also do that in non-medical contexts. So sometimes causal directions is also ambiguous. So here we have information about recent college graduates and income. So the income of people with higher education, and usually you probably have heard about this. So the more education you have, the higher income you have. This is the income, and then the blue bars is, well, the different categories here is higher education. But as someone was pointing out that studies this, does schooling lead to higher earning? So the more school you do, the more earning you have, or does higher earning potential lead to more schooling? So people that are actually already going to make more money, they actually get school to fulfill that sort of inner desire. So it may seem obvious at first, but if you think about it, things often get more complicated. And there's a good article here from this person on towardsdatascience.com. Correlation is not causation, and his picture here that kind of illustrates some of the points. The sun causes ice cream to be around or to melt, and sun also causes sunburn on people, and the ice cream melting and the person sunburning are correlated, but they're not causing each other, right? There's another variable that is causing those two variables behave a certain way. And there's also all kinds of issues regarding biases as well, cognitive biases that need to be considered when we interpret data and think of correlation and causation. And these are summarized in this article over here. Lastly, let me just mention about a correlation matrix in Python, which you can see from the other videos as well. And it's easy way to carry out this function. Is just really one function attached to your data frame. And you can find detailed information about this function from the documentation of pandas. And you will see the values in the matrix, all the correlation values between -1 and 1. Negatives are negative correlation, and positive numbers are positive correlations. And I hope this was useful for you, and I'll see you next time.